Welcome friends. So we will discuss now short transmission line. What is short transmission line? Any line which is less than 100 kilometer. Any line is less than 100 kilometer length. And equivalent circuit, it has no shunt admittance. No shunt admittance. So what is the equivalent circuit? It represents a resistance, series inductance. We have Vs and Is at the sending end, and we have Vr and the Ir at the receiving end. So this is R, this is X. So altogether Z is equal to R plus Jx. So now if we analyze this equivalent circuit of a short transmission line, it can be written, the KVL equations can be written as, you see, Vs, that is equal to Is or Ir, whatever you can say, because both are same, Is or Ir. Let me write Ir. Ir into Z, Vs is equal to Ir into Z plus Vr, and also we can write Is is equal to Ir. So now if we compare with this equation, Vs is equal to AVr plus BIR, and Is is equal to CVR plus DIR. So we can write, so this is A actually, so it is 1, so we can write A is equal to 1, B into IR, so Z into IR, so we can write B is equal to Z. Is is equal to CVR, so there is no VR, so C has to be 0 here, and D is equal to 1. So these are the 4 parameters A, B, C, D. A is equal to 1, B is equal to Z, C is equal to 0, and D is equal to 1 for short transmission line. Now let us draw the phasor diagram of this equivalent model. So we can take VR as our reference phasor. So let us say that VR as our reference phasor. Now what is IR? IR actually the current at the receiving end. Now by the virtue of nature, the currents are lagging in nature. So we can assume this is the lagging current IR, and this is phi. So phi being power factor angle. It's a lagging in nature. Power factor angle, it is lagging. Now this IR current is flowing through R and X. So it will cause a drop. First, a potential drop is IR into R, and then it will cause a drop IR into X. So IR into R, that is the resistive drop, it stays in phase with the current. So it should be located at this direction. It's a parallel with IR, so it should be IR into R, and IR into X is the reactive drop, so it should be 90 degree leading. This is IR into X. So the phasor summation of VR, plus IR into R plus IR into X will give you Vs. So this phasor essentially be Vs. So from the phasor diagram, you can derive something interesting. So you extend this line like this and you drop a perpendicular. Now this Vs, the angle between Vs and Vr is called delta. Angle between Vs and Vr is called delta. It's called load angle. We will talk on this load angle later. Now in practical case, delta is very small. Delta is very small for practical reasons. So we can say that this, it is, if it is O and if this is A, this point is A, and if this point we can say A dash, then we can say OA is nearly equals OA dash for delta is small. So if this is okay, then this part, let me divide, let me say this point is B. So your OB is VR. Let me consider this point as C. So BC is IR into R cos phi, because if this is the phi, then this angle should also be phi, and this is also CA. What is CA? CA is nothing but IR into X sin phi. So using this three, we can write Vs is nearly equal VR plus IR into R cos phi plus IR into X sin phi. So from here we can write as Is is equal to IR for short transmission line. We can write Vs is equal to VR plus IR or I rather R cos phi plus X sin phi. Now what is voltage regulation? What is voltage regulation? It is no load voltage minus full load voltage by full load voltage into, of course, 100. So now in short transmission line, you can see if your R is 0, that is no load. If you have no load in the receiving end, then Vs becomes VR. So no load voltage for short transmission line basically Vs. No load voltage for short transmission line basically Vs. And full load voltage of the short transmission line is VR. So Vs minus VR by VR into 100%. And that is the formula of regulation for short transmission line. So we have studied the equivalent circuit of the transmission line. Then we have studied the phasor diagram. Also, we have evaluated the ABCD parameter of the transmission line, and thereafter we have deduced what is the voltage regulation of the transmission line, or rather short transmission line. In the next lecture, we will demonstrate a numerical problem to you to make you understand the theories behind these short transmission lines. Thank you.